A canal is 300 centimeter wide and 120 centimeter deep. The water in the canal is flowing with a speed of 20 km per hour. How much area will it irrigate 20 minutes if 8 centimeter of standing water is desired? So we are looking at something like this. We have a canal, right? There is flow of water. Okay, water is coming out onto what? Onto a land. So here there are a few things given. One is the width and the depth. Okay, so let me show this. Width being the left to right, depth being from up and down. Okay, so this is your canal. Can you see that? Width is from left to right, depth is from up to down. Right, left to right and up and down. Okay, length and width. Then the rate of flow of water, that is this particular thing. Okay, it's coming from 20 kilometers away in 1 hour. Yeah, so 20 kilometers away from 20 kilometers away in 1 hour. So those are the things, and it is how much area will it irrigate in 20 minutes if 8 centimeter of standing water is desired. That is, it is let onto a land, and what we have here is the standing water, in the sense this length is 8 centimeter. So how much area can it cover is the question. Okay, how much of this area can be covered if it's allowed to stand for 8 centimeter high. So why is it required and all of that? That is to do with irrigation, and they have to keep it as a wetland for some time in some ways. Not exactly wetland, but you guys know. If not, you guys have to see all of that. Why is there a standing water that's required and all of that? Okay, so I'll have a small diagram. So what do we have here is the water coming out at a speed of 20 km per hour. The thing is, everything is in centimeters. So we have to convert this to 20 kilometers to centimeter. So 20 kilometers is 20 into 10 to the power of 3 meters. Okay, kilo is 1000, so that's 10 to the power of 3. And for centi, you have to multiply with 10 to the power of 2. So let me do it in the next step, because this is what you guys get confused about. 20 into 10 to the power of 3 into 10 to the power of 2 centimeter, because every meter has 10 to the power of 2 centimeter. So as a whole, we have 2 into 10 to the power of, here let me write this as 2 into 10. Okay, 20 I'm writing it as 2 into 10. Okay, don't get confused. I just want to put all of this numbers as power. So 1, 2, 3, 4, 5, 6 centimeter. So 2 into 10 to the power of 6 meter per hour. So much of water is coming out. Means what? A molecule which is 2 into 10 to the power of 6 centimeters away, okay, say this point, will come out of the canal in an hour, right? Okay, so the basic conversion has been done, and we have the width to be 300 centimeter, depth is 120 centimeter, and we have the height to be, yes, 120. Right, and now the working. So we have the first thing is, what and all should we write? Rate of flow. Actually, let's write given first. Let's be organized here a bit. So this is a 3-marker question clearly. Rate of flow is, we converted to centimeters, so 2 into 10 to the power of 6 centimeter per hour. We have the time to be 20 minutes, so 20 by 60 hour, or if not 2 by 6 or 1 by 3, 1/3 of an hour. And what else? Everything else I think I have written in the diagram itself. Yes, and the amount of standing water. So we have the height of standing water is 8 centimeter. Okay, all the unit looks good. So yeah, it's just a matter of conversion. So volume of the irrigated land, I guess, no, water is equal to volume of water out of the canal. Okay, so we have the following. Yeah, so what we have here is volume of the irrigated water will be length of the irrigated stuff and breadth and height. So this is nothing but your HI. This is equal to length of the canal, breadth of the canal and height of the canal. Oh yeah, I forgot to mention about the height. How will we figure out the height? Height of the canal is nothing but rate of flow of water, rate of flow into the time which the water is allowed, time of flow. As simple as that. What does it mean? It means that, say, I have switched on for half an hour. What happens to this? What we discussed was this will reach out of the canal in 1 hour. So in half an hour, where will this be? This will be half the way. Half an hour more, it will come out, right? Now within 20 minutes, whatever water was, say, in front of the canal, like somewhere over here, all of this water will come out, is it not? So that is basically from this point to this point, that entire length of water will come out. Agree? And that's what we are going to make use of over here, right? The same concept has been mentioned over here. So the height or the length of the canal or pipe can be obtained with this particular formula. Yes, we have done with your exercise questions also, but yeah, these are all revision questions. See to that you guys learn. This is nothing but area of irrigation. So area of irrigation into height is 8 centimeter is equal to length over here is 2 into, oh sorry, this is not height, this is length. My bad, this is length. So length of the canal is how many minutes? 20 minutes. It's over here. 2 into 10 to the power of 6 meter per hour into 1/3 of an hour into the breadth is 300 into 120. Okay, so we have this, and let's see what and all will get cancelled now. So we have 3 and 300, then 8 1s are 5s are 15, right? Anything else? Nothing. So we have this to be 300 into 10 to the power of 6 7 8. So basically so many centimeter square. This much of area is being irrigated. Again, they have not asked us to express in terms of centimeter or meter or anything, so we can just leave it over there. So this is also correct, right? Why to make a mistake and all of that? Whatever answer we got, we have done it. Okay guys, yeah. So here the star goes to this point, conversion. That's important, and yes, this part is also important, right? And here I think I didn't explain it slowly. This part is your area, length into breadth is your area of the canal, not the canal, sorry, area of the irrigated land. They want the area, remember, they don't want length and breadth, they want the area. They have given the height, they want the area, so that's why I've written area of the, oh yeah, we need to end up with writing the final answer. So irrigated area is equal to 300 into 10 to the power of 8 centimeter square, and that would be your answer.